Hi guys, we're starting our trigonometry unit here, and this will be our last unit we do for the year. Hopefully a lot of what we do today is review, and we're gonna jump right in and start with, maybe you heard a story, I don't know what they told you in geometry, but the famous mathematical princess Sokotoa. So there's a lot of funny stories with that. If you're bored, you can go ahead and look it up on the internet. If we were in class, I'd probably tell you some goofy story about a princess who got mad and kicked something, and so she was looking for a name. Her father called her Princess Sokotoa because she had to go soak her toe in the waters. And I'd probably post an ugly picture of a toe all tore up. So maybe if you're lucky, I'll still do that. So Sokotoa is just a way for us to remember sine, cosine, and tangent. So if we look at a right triangle, I'm going to draw a right triangle here. And then I'm going to pick one of the acute angles and I'm going to call it theta. Just a Greek symbol. You could call it x, you could call it whatever you want, but a lot of times we use theta. We're going to be fancy here. The hypotenuse is always the side that is across from the right angle. If this is the angle that we're referring to, then this side would be the adjacent side, the side that's touching it. And then this side over here would be our opposite side. It's opposite from the angle that we are talking about. So sine, cosine, and tangent. To find the sine of angle theta, we would do the opposite side over the hypotenuse. So this would just be opposite over hypotenuse. To do cosine, we would do adjacent over hypotenuse. And hopefully, again, you're remembering this from last year in geometry. Tangent of an angle is the opposite side over the adjacent side. Now, these next three might look brand new to you. And what these are just reciprocals of sine, cosine, and tangent. It's called cosecant, secant, and cotangent. So cosecant is just the reciprocal of sine. So what I would do here is I would take my opposite hypotenuse and I would flip it. So cosecant is really just the hypotenuse over the opposite side of a right triangle. Secant is going to be the reciprocal of cosine. And I would just flip my cosine, hypotenuse over adjacent. And then similarly, cotangent is just 1 over tangent, or we would say adjacent over opposite. So I'm pretty sure you did not do those in geometry last year, but that is our cosecant, secant, and cotangent. Now, if you want to make a note to yourself, theta is just a Greek symbol, and this just is what we're going to use to represent an angle measure. All right, let's try a few of these. So notice I want the 6 trig functions. I want sine, cosine, tangent, cosecant, secant, cotangent. Let's try. Now notice I'm starting off, I am not giving you all 3 sides of this right triangle. So more geometry here. We've got to do Pythag. So you might want to make a note to yourself, hopefully remember Pythagorean theorem, but use a squared plus b squared equals c squared to find the missing side. See here, this is my theta. This is the angle that I'm going to be referring to in this problem. I'm missing this side. So I'm going to do a squared plus b squared is equal to our missing side, which happens to be the hypotenuse. You can just call that x if you don't want to use a, b, and c. And then do the work to find this. Again, hopefully this is pretty easy. I know I reviewed over this back when we did ISET practice, but our missing side, the hypotenuse, is 13. So this right here is our hypotenuse, and that is 13. Now, here's theta. That's the angle we're referring to. 12 is opposite from that, so I'm going to call this the opposite side. And then 5 is the side that's touching it. That's the adjacent side. So now all I have to do is go ahead and find my 6 trig ratios here, my trig functions. So sine is opposite over hypotenuse. So the sine is 12 over 13. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I'm just going to leave those as fractions right now. Cosecant is the reciprocal of sine. So I've got 13 over 12. Just going to flip it. If I know sine, I'm just going to flip it to get cosine. Or sorry, cosecant. To get secant, I'm going to flip my cosine. So I've got 13 over 5. And cotangent is 5 over 12. So if you get sine, cosine, and tangent, these three should be easy. Now, you are going to need to remember which ones go with which. So let me just show you a quick little trick that I do to try to remember that. All right, so I wrote down sine, cosine, tangent here. And what I usually do is tangent hopefully should be pretty easy just because it's cotangent, it's got the T in it. Sine and cosine, sometimes these two get confused. So what I like to do is look to see, okay, so this is a vowel, this one has a vowel in it. And then notice the C and the S were just flip-flopped over here. Just a silly way to try to remember it. And then the oddball goes with sine. So sine just has, C, C, S. I don't know, that's just one way I try to remember those. All right, let's go ahead and try another one here. So here is my angle that we're going to be, my acute angle we're going to be looking at this time. This time I have the hypotenuse. The hypotenuse is 10. And then this would be the side that's opposite from the angle that we're looking at. And we need the adjacent side. So the adjacent side is the one that's missing this time. I'm going to do Pythagorean theorem, a squared plus b squared equals c squared to figure that out. So I'm going to do 1 squared plus b squared equals 10 squared. You could have done a squared plus 1 squared, doesn't matter. 1 plus b squared is 100. Subtract the 1 from both sides. B squared is 99. Notice we are going to get a radical answer. I do not want decimals. So b is 3 radical 11. So these answers are definitely going to be a little bit uglier this time. All right, sine. Sine is opposite over hypotenuse. Nice and easy there, 1 over 10. If you want to, go ahead and just do cosecant while you're at it. Just flip that 10 over 1, and you just get 10. Cosine is adjacent, 3 radical 11, over the hypotenuse. So 3 radical 11 over 10. Notice these answers are getting a little bit uglier. If I flip that, I've got 10 over 3 radical 11. You cannot leave a radical in the denominator, so we need to rationalize it. So now I've got 10 radical 11 over 3 times the square root of 11 becomes 3 times 11, and that's 33. All right, one more, tangent. Tangent is opposite over adjacent. 1 over 3 radical 11. Again, I cannot leave that answer that way, so I would need to rationalize, multiply the top and the bottom by radical 11, and then I get radical 11 over 33. So that would be the answer for that one. Now, if I'm going to do cotangent, it's going to be really silly for me to flip this one because then I have a radical in the denominator again. So I'm going to go ahead and just flip my original. So if I flip 3 radical 11 over 1, that's just 3 radical 11. All right, the next video is going to jump into some more geometry review.